And again, we're excited to get started, so welcome to today's webinar, Building Serverless Web Applications. Our presenter today is Vishal Singh. Vishal is a Senior Product Manager with AWS Lambda. Today with us, we also have a great Q&A moderator who is ready to answer as many questions as you have. However, we do have hundreds of participants and only a couple of moderators, so please note that we might only be able to answer some questions here today. We will be leaving the presentation team with the Q&A log, so they will be able to follow up after the presentation in some form. But again, if you don't hear back, please do reach out. We'd love to hear your questions and keep those questions coming. So with no further ado, let's go ahead and begin. Vishal, the floor is now yours.
Hello, everyone. This is Vishal Singh. I'm a Senior Product Manager at AWS Lambda. Thanks for joining. So what do we expect from the session? First of all, we're going to look into the concepts behind serverless technology. We will specifically go into AWS Lambda and API Gateway. Next, we'll look into design patterns around serverless applications. And then finally, we'll look into certain tools and frameworks which will help you create serverless web applications. Let's get started. AWS Lambda. So AWS Lambda is a compute service which is event-driven. It can scale up to the request of your events, and there is no need for provisioning any servers. Let's look at its benefits. So as I mentioned, no servers to provision or manage, which means that you could focus on your business logic to build virtually any type of application or any backend service. AWS Lambda scales with usage. So it will scale with your rate of events are coming to AWS Lambda. And idle, which means that if the backend is running for a certain period of time, you only pay for that period of time. And then availability with AWS Lambda is built in. It is fault tolerant, and error handling is handled for you for certain workload types. Here is a quick overview of serverless framework using AWS Lambda. So AWS Lambda is event-driven. Events could be requests to your API endpoints. It could be requests coming in from an objects being uploaded to S3. There are various other types of integrations which we provide with AWS. It offers continuous horizontal scaling. So these functions could get automatically scaled horizontal to match the rate of events. And then, as I mentioned earlier, you pay by usage based on the number of requests coming into AWS Lambda as well as the size of the function size. One important point to note here is AWS Lambda supports function versioning. Versions are immutable copy of code and configuration. And there is also a concept which we support called aliases. These are mutable pointers to version. And so what that means is that you can have a dev alias pointing to a $latest version, which would be the version you are working on in your development teams. And then there could be aliases which point to beta or prod versions. And this is how you maintain sort of version management, which is very important for your workloads. This also enables rollbacks, your stage promotions, and lock behavior for certain clients. We also support environment variables with AWS Lambda. Environment variables are key value pairs, and they are available to you at the function code via standard environment variable access. For example, process.env, os.environ. And you can optionally also encrypt these environment variables via AWS KMS. You could use the default service key, or you could also use your own key. You could also do client-side encryption to protect certain sensitive passcodes or information stored in the environment variables. Here are the common use cases. Of course, in today's webinar, we are focusing on the web applications with the backend being on AWS Lambda in a serverless design pattern, but there are also other use cases which I'll quickly go over. So as I mentioned, you can have web applications like static websites, complex web applications. You can have packages which could be created using Flask and Express, for example, with various backends possible. Virtually any type of application and backend services are possible here. Mobile backends, IoT backends. Another common use case is for data processing. So we support real-time processing of data, for example, plugging into DynamoDB streams or Kinesis streams, MapReduce jobs. You could also do batch processing with AWS Lambda. Another common use case is to develop chatbots and voice-driven applications with Amazon Alexa. So this is where events come in as compute and backend on AWS Lambda can execute the business logic. And then another common use case is policy engines for autonomous IT related workloads, where you could extend your AWS services using AWS Lambda for infrastructure management and lot of related aspects. Let's now take a look at Amazon API Gateway, which is the other service which is very important for creating these serverless web backends. So API Gateway is a completely managed service which helps you publish, deploy, secure, and manage your API endpoints. The backend endpoints could be your AWS Lambda functions, or they could be your EC2 endpoints, or it could be any other HTTP endpoints or HTTP proxy endpoints. Here are certain important traits of API Gateway. So the most important one, it helps you unify your various microservices under a single API front end. It also helps you authenticate and authorize your API requests. Provides supporting and is secured. In a nutshell, API Gateway helps you monitor your API calls, the traffic coming into your APIs, as well as hundreds and thousands of endpoints accessing your APIs, and it's all done in a controlled, monitored, and secure manner. Let's take a look at what is meant by a unified API. So you could have on-premise servers, for example, and you would want to put that behind an API gateway, proxy. You could have various workloads on your AWS account, certain EC2 instances, several Lambda functions, could be other API services, and then API Gateway acts as the front door to manage all of these workloads for your application. So it provides a very unified endpoint along with support for caching, as I mentioned earlier, support for the DDoS protection, also throttling capabilities provided right out of the box. Authorization, there are three ways to provide authentication and authorization for your API endpoints. The first one is SigV4, and this is where you can use AWS credentials such as the secrets and the access key, and your request could be signed using SigV4. This is what Amazon AWS uses to secure the various web service endpoints, and combined with Cognito, which provides you a temporary credential for your role. You could actually have authorization at a per method level using this method. The other one could be using a custom authorizer, and this is useful when you have certain bearer token which you want to authenticate, which is implemented as a Lambda function. For example, you could use here an OAuth call, or you could use a JWT token verification method using this scheme. And then you could also have API keys, which are used for per method authorization, but also for usage plans, so that you could say, what quotas are assigned to each key. You could also do throttling at the API keys level. So these are the ways by which you could, secure your backend endpoints. And then you have support provided by API Gateway for throttling, DDoS protection, both layer 7, which is counterfeit request, or layer 3, which is SYN floods, protection are provided out of the box. There is CloudFront in front of API Gateway, and this is a capability you get by using API Gateway. There is also support for throttling. So by default, you get 1,000 requests per second with a burst of 2,000 requests per second. And definitely, if you want to go over that request, then you could definitely, get those changed. And along with, combined with the usage plans, which provide you the quota for your API keys and throttling, you are able to really manage and protect your backend from the requests. And then API Gateway provides you auto-scaling. You could also specify caching so that not every request which is not needed goes to your backend, and the cache would be able to serve those requests. API Gateway also provides support for stage variables. They're very similar to the environment variables, which we spoke about in AWS Lambda. And here you could use stage variable to store configuration values. They are available, in most of the fields. They're accessible as a context object parameters, and you could have from the Lambda function through the HTTP endpoint, or from the custom authorizer, you should be able to access them. And stages really help you with defining the lifecycle stages of your APIs. For example, you can have a dev stage and a prod stage, and then you would be able to manage this out without making changes to each of the endpoints. And let's now take a look at the design patterns, which is the core theme where we have to focus on serverless web applications. Using API Gateway and Lambda. And which usually is a big single application which is serving your web requests, and it is it has certain drawbacks. One is because it has interdependencies between various components. It's hard to iterate fast on a giant monolithic architecture a web application. Because of the same reasons, it's hard to scale efficiently because a certain component needs to be scaled. You have to manage the dependencies on other components. Of course, management of and maintenance of these applications are important. So your continuous integration or continuous deployment becomes slower. It's time consuming, and which adds to reliability challenges with your application. Let's contrast this with benefits of a microservices architecture. So API Gateway combined with AWS Lambda are building blocks for you to build microservices. And then here the benefits are because these are distributed, they are smaller Lego blocks for applications. You get increased agility. because they are independent units. They are easy to scale. Both API Gateway and Lambda, as we mentioned earlier, provide that scaling to match the rate of incoming requests. So you get the benefit of scale. And then because the developers can focus on the business logic without thinking about provisioning of servers or any of the operational aspects, administration, capacity, things like that with the serverless design, they can focus on innovation. And this all amounts to reduce human errors and better stability of the applications. But let's take a look. If you were to create a monolithic web application using the serverless model, how would it look like? And so, as we said, that here the design is event-driven. So you have various endpoints. For example, in this case, you have a get pets endpoint or put pets endpoint. There is a delete method for your resource. There is a get to describe a certain pet ID. There is one for put. And you would note that all of these requests are handled by this one giant Lambda function. So this is one example. Like even with serverless, you have one big Lambda function actually routing the calls and managing all of that in one place. Of course, this has the same drawbacks which we mentioned earlier. So not only when you're dealing with a legacy architecture, you have a sort of a monolithic design, but you also have this when you are creating one big Lambda function which is handling all of these requests. There could be some benefits, and depending on your requirements, you could say that it's easier to comprehend because this becomes less distributed, and so deployment could be faster. So there could be certain benefits based on the requirements. But it's a single handler which is handling all the various types of the HTTP methods in your application. And as the complexity of the application grows, you would imagine that it would become hard, more rigid, and less flexible as it scales out. And you're dealing with this one single function, which multiple people may try to update, and have to have a routing mechanism built in within that handler. And all this amounts to a larger, more error prone and a larger blast radius than you would otherwise want to prevent. And so let's see how we can make this better. And so moving from a monolithic to a microservices architecture means that you would have multiple Lambda functions handling each of those various resource methods. And so this would turn out into a one Lambda function per HTTP method. So as we, if you recall, the get pets or put pets would map to, one Lambda function for that kind of request. A delete pets would also be another Lambda function. And so a distributed team, multiple team can actually work on each of these as a backend Lambda function independently, and then bring this together, in a microservices architecture manner. As you would imagine, it has lots of benefits. Easier for teams to work autonomously. The components are separated. There is a fine-grained deployment. So as integration testing becomes more important when all of these microservices come together, the independence of these deployments help a lot. Can be easier to debug because you're not dealing with the giant monolithic architecture, but it's microservices, so smaller chunks of your application, and this all amounts to your development being more agile, and you get all those benefits out of it. Sometimes you can look into some of the cons of these architectures where because you have so many different services, yeah, the request coming in from an endpoint, going to a particular Lambda function, where did the request fail? It could be harder to debug. And so I would want to call out that we recently went GA with support for X-Ray, which is a service which helps you trace these requests and really help diagnose the problems in a serverless space. So if a request is coming in from an API gateway endpoint, going into AWS Lambda as a backend function, which is implementing the logic for that request, which calls into say a DynamoDB database, you could use X-Ray service to trace the specific request all the way from the endpoint which is requesting to the Lambda function to the DynamoDB database, and it makes it really easy for you to debug any issues along that pathway. You can, a lot of times for most applications in this architecture, you would have multiple Lambda functions. So management of those Lambda functions is also something you would want to think about. And this is where we refer you to SAM, which is the serverless application model. And in a subsequent slide, I'm gonna go into the details of SAM. And so how does it look like when we put all of this together for a serverless web application? So this is where you have your users, and you can store all of your static content in an S3 bucket. So these are the cascading style sheets, your JavaScripts, various images. They are all in an S3 bucket. So then in a very serverless manner, so you don't have to think about any provisioning of servers, and you can just store all of that in that S3 bucket. API Gateway here handles all of your application routing with all of the benefits we had mentioned about traffic management and providing security of your backend, along with caching and providing authorization and authentication via the various schemes which are supported. And Lambda functions have all of your logic behind your website. Create, read, update, delete, all of the CRUD operations which form the core of your application, each of these are implemented as a Lambda function. And so here you go. This is your model of a serverless web application in a microservices-based architecture, which can help you actually virtually build any kind of web application with the scale, the protection, the throttling, all of those aspects given and handled by the managed services, and you don't need to provision any servers, no administration, no operational aspects which comes with maintaining servers. And let's now take a look at managing, because once you build this application, how do you manage it? Because you need continuous integration, continuous deployment. You need to specify these applications. And this is where serverless application model comes in. And what serverless application model, or we also refer to as SAM, it helps you build templates. And they help you define your serverless application. So for example, a template can define an API gateway endpoint, a couple of Lambda functions, a DynamoDB database, and you can specify these in an easy to use YAML file. And then it could be deployed using CloudFormation. So CloudFormation can read out these SAM templates and help you deploy. So once you auto as a SAM application, the steps to automate your CI/CD pipeline are handled for you. So this is how a way for you to manage your application, serverless web applications. As I mentioned, CloudFormation is used to deploy these applications, and SAM, you can think of it as an abstraction over CloudFormation. More of an easier to use and read abstraction over CloudFormation, but underneath the covers, it does transform into CloudFormation. So that's why it actually supports everything which CloudFormation supports. You have new serverless resource type. So like, for example, your functions, APIs, tables, and so you can easily specify your serverless web application using SAM. It's an open specification under Apache 2.0, and you have a lot of examples in the AWS labs and GitHub, which has various templates ready for various scenarios and use cases. You can go through that and take a look. Contrast it with the CloudFormation template, which looks like this. I know this is like a finite chart. But just, what I wanted to specify is that's the equivalent SAM template you have, where you can specify your resources for your serverless web application. In this case, it has a function which has the code in the S3 bucket. That's the handler. The function is using a Node.js runtime here, and a policy which is applied, which is providing the DynamoDB read-only access. Event in case of this scenario is an API gateway endpoint, and this is how you specify the path, because all the methods are mapped to your backend. And then you can specify a table which helps you maintain a continuous integration and continuous deployment cycle for your web application. And then finally, I would want to specify certain frameworks which can help you with your development of your applications. We have serverless.com, Apex, Cloudia.js, Sparta, Chalice, Zappa, and then there is a wide community behind each of these frameworks. You can go and check them out. Some of these, for example, Cloudia.js helps with Node.js application development. Chalice is focused on Python to develop your applications. And they help you really specify the API endpoints and the functions, and allow you to with managing and creation and deployment of your applications in a continuous way. So definitely recommend you to check these out. Let's take a quick look as just a sample for Cloudia.js. So you have an app.js here. You could use API Builder as a dependency. So here, requires Cloudia API Builder. You create a new instance here, export your API. In this scenario, this is a very simple application, which is like, hey, give me an endpoint, say hello for the API, and it returns the hello world string. And then all you do is Cloudia create, you specify the region endpoint for your application. In this case, it's US East 1, and then just deploy. And what this does is deploys the API endpoint along with the Lambda function, all of that with one statement here. And then we look at Chalice, which is a Python framework to manage your serverless web application. So in this case, you have that app.py. So you import Chalice. You again create an app name, hello world. You set up for your API endpoints. You define again the same hello world example. And this is how you specify and ease out like your API gateway endpoint being available here. the name of, you can deploy these functions using the deploy command, and the childless application would be available at the HTTPS endpoint. The endpoint, here would be the actual endpoint. For ease of use, it's specified as endpoint dev, and you can actually create different endpoints for your dev portions, another one for your for prod, and you can manage them using these framework. And definitely, these are just for sample sake. These are just basic examples, but you can try out different frameworks. Look at their documentation. There is a community behind each of those frameworks. You can also reach out to us with your feedback in terms of how we can make it easier for you to deploy, manage, publish the serverless web applications using API Gateway and Lambda, and help you focus on the business logic of your application. And while on our side, we maintain, manage the infrastructure, behind these applications, so that you don't have to worry about, any provisioning of your servers, any operations, any administration aspects, when you're actually creating virtually any type of web application or backend services, which help you create these applications. So let's do a quick wrap up here on the serverless application model, which helps you define your serverless application. I just want to call out again that SAM is an open specification under Apache 2.0. There is a community behind that. We are continuously looking into how we can take feedback and improve the serverless application model. It is integrated with code pipeline and code build, which allows you to set up a continuous integration, continuous delivery pipeline for your application, and such as your serverless web application. There are lots of frameworks out there to help you get started quickly. Just quick recap: Cloudera.js to manage your Python web application development. You have Zappa, Sparta, Apex, Chalice. Cloudera for Node.js and Chalice for Python. I set them in a reverse manner. You also have AWS Serverless Express, Lambda, and the serverless framework. So a lot of frameworks out there for you to get started quickly. And then one other thing I would mention, that if you are just getting started, start small. You can look into your existing applications. You can actually put in an API gateway endpoint, keep the application as is, and then you can do what we call as, just try it out, see how the request work out. The model of that one, giant big Lambda model as a monolithic application to begin with. And then you can do a lift and shift where you can pick up portions of your application. And this is a common use case for when we actually see a lot of developers use it, is that you can focus on a specific piece and lift that and move that over as a Lambda function implementation. And so what this helps is, you don't have to change all of your implementation to begin with, but you can definitely start small. And if you're starting on a new use case, then you can just try out, simple resources, see how it works with an API gateway, each Lambda function for each of the methods. You can try to keep it open to begin with from an authentication authorization mechanism, and then add using various schemes. For example, you could use the AWS SIG v4 to protect the backend. You can also do custom authorizer, and then you can try it out. What works best for your model. You also have various SDKs available. So, for example, there is an SDK for iOS. There is an AWS SDK for Android, which helps you with your mobile applications. There's JavaScript SDK, which helps you with your web application. And so they provide a lot of these functionality to access AWS services. In fact, for the authentication of SIG v4, the SDKs help you use the access and the secret key to sign these APIs. And so you get a lot of benefit when you use those, do that yourself and you get those helpers.